All right, today's lesson is on compositions of functions. This is a new topic to Math 2 students. One of the things that I'd like you to think about is I've tried to give an example of perhaps a model or a spokesperson who has to come in, and the person who walks out the door to report to the job may not look like the person you see sitting in front of the TV camera once they're all made up. So I try to use the analogy sometimes of like having someone walk in the door, they immediately sit down in someone's chair and they do makeup. They fix them up, they look beautiful. Then they get up out of the chair from makeup and they go in there and someone sits and they do their hair. And so then they come out looking well made up, hair's in place, looks perfect, makeup looks in place, it's perfect. So the person that you see walk in the door to the station and the person you see walk out of the two hair and makeup booths to go outside to be on the TV news, they're not looking the same. So composition of functions, trying to use an example of doing that. So if I look at my little picture, I tried to find diagrams that would actually help you conceive what a composition of function is. So if I input something into the first function f, okay, I'm going to get something out of f. If I take what I get out of f and I put it into g next, then I'm going to get something else out of G, and that would actually end up being what I see. So it's like here, if I talk to you about going ahead and going through hair, and after we walk out of hair, we go straight into makeup, and then what walks out is somebody who's totally new. That's the analogy, or at least that's the way I'm trying to get you to think about it. Obviously, we're not doing hair and makeup. We are trying to do composition of functions. So part 2 of the lesson that I actually began yesterday, and I split this into 2 sections, is composition of functions. We're going to build a new function using 2 or more functions. Now, the way you write it is it's going to have a lot of parentheses. This version of the way we write it has a lot of parentheses. You still say f of g of x. You just keep adding the ofs. Or it can be written this way without the extra parentheses, and it's still, that's supposed to be a little o. It's not a circle, it's not supposed to be fog, it's supposed to be f of g of x, spoken like this. So the way that we speak it, no matter which way we see it written, is the same. All right, in terms of doing a math equation, I found a different diagram that says if you input an equation or something related to x into the f of x function, that might be the first function, f of x, the stuff that comes out of f of x is going to be pushed into g of x, and the stuff that comes out of g of x equals the final answer. So we're going to have to actually use 2 equations, 2 functions to get one final answer. So let's just jump in and see if we can do example number 1. Okay, we have our 3 functions. We have an f function, a g function, and an h function. And I usually tell the students, I'll say go to the number or go to the end and work your way out. So what we're going to do is we're going to look first at -3. -3 is in place of my x. -3 is going to go into g first. So I'm going to go up here and I'm going to say g of x is 3x. So g of -3, though, would be 3 times, and I'll color code this, my input now is -3. So 3 times -3 is -9. Now I'm not finished, because now what I'm going to do is I'm going to take what comes out of the g function and I'm going to put it into the f function. Now yes, that is opposite of what my diagram showed you, but I'm doing what order is mentioned for this problem. Okay, you start with the number at the end and you work your way out. So it's like you work on the inside and come out. Now, since I'm only halfway finished with this problem, I'm going to take the answer, -9. I'm not done yet. That's not my final answer. And I'm going to put that answer into what? We said we was going to put it into f. So now I'm going to go to the f function and I'm going to use -9 there. So my f function says 2x minus 1. Well, in place of x, it's going to be what? Well, it's going to be -9. So my new input that replaced x is -9. So -9 times 2 is -18 minus 1, which is -19. The second answer is the final answer. Okay, I did it in the opposite order from my diagram, but still I had to go through two separate functions. I used function G and I used function F. I got one answer, I put it back in here, I got a second answer, and the second answer is my final answer. Okay, let's go to number two. Number two, H of 7. This time, I see the parentheses. Again, start on the inside and work your way out. So which function do we go to first? H. H is the function we're going to use. So I'm going to put what number into H? 7. So I'm going to go and I'm going to find the H function and put 7 in there. So 7 squared plus 1. Again, we're replacing X with 7. You might want to get your calculator. Some of these numbers do get large. So that's going to be 49 plus 1, and 49 plus 1 is 50. Is that my final answer? No. This is a composite or a composition of functions. So now I'm going to take what comes out of H and I'm going to put it where? Into F. So F, the F function, oops, wrote the wrong thing. The F function, I'm going to input 50. So 50 goes into F. So that means my function says 2x minus 1, so 2, take out x minus 1. So 50 goes where x used to be. So of course 50 minus 1, or 2 times 50 minus 1, turns out to be 100 minus 1, which is going to give me 99, final answer. All right, we're ready for number 3. Same thing, go to the end of the function, 24. 24 is going to go into H first. This is going to give me a pretty large one because H is x squared plus 1. I'm going to erase so that it's not quite so messy, just to kind of clean it up a little bit. All right, so I'm going to go to H and I'm going to put 24 in there. Well, H says x squared plus 1, so now it's going to be 24 squared plus 1. And I think if you do 24 squared plus 1, you get 577. It's a pretty large number. Is that my final answer? No. After I do the H function, I'm going to take the answer from H and put it where? Into G. So G function says 3 times x. So now I'm going to put 577, which is the answer, into G function. So it's 3 times x. Take out the x, replace it with 577, and I'm going to get a 4-digit number that is what? 1,731. Final answer is the second answer. All right. Okay, so again, we're using 2 functions. We're running this number through 2 functions, and the second answer is the final answer. Where do we start in number 4? I hope that you know that we start with F. So we're going to put 9 into F. So if I put 9 into F, 2 times 9 minus 1 is 18 minus 1, which is 17. After we do the first answer, where do we put that? Into H. So now I'm going to come up here to H, and I'm going to put what in there? 17. So H is 17. 17 squared plus 1, because that's what H is, x squared plus 1. And that's going to give me a big number too, 17 squared. I have to do it because I haven't done these. 17 squared plus 1, and I got 290. Second answer is my final answer. All right, number 5. Which one do we start with first? Okay, we're going to put 0 where? Into F. Put 0 into F, so it's 2 times 0 minus 1. Because that's what I have if I go to the 0 function and put F function and put 0 in it. So I get negative 1. This is where you got to be careful. If you don't input the negative number right, this answer is going into G. So take G and put what number in there? Negative 1. Okay. G, oops, this is not the one. 3 times negative 1 turns out to be negative 3. Final answer is my second answer. All right. Take G. G's got a negative 4. Negative 4 is going to go into the G function first. So the G function at negative 4, the G function is 3 times x, so it's going to be 3 times negative 4. I get negative 12. Now I'm going to put 12 where? Into the H function. So take the answer, go into H. So H of negative 12. And this is where you have to be careful putting it in. Okay. I actually need to put negative 12 in parentheses, especially since it's negative, because I'm going to square that number and add 1. If you don't put your negative in parentheses and you use your calculator, you're going to get a negative answer. The answer should be positive. This is going to give you one positive 144 because negative times negative is positive. And when you add 1, you get 145. Positive number. Final answer is 145. All right, most people picked up on the composite functions or composition of functions with numbers pretty quick. I even did several of those for Candy, and we started pulling sticks. So I actually didn't work out every single problem of the previous 6. However, starting with 7, now we have to contend with the fact that sometimes we don't have a number. Sometimes we have letter X. So what about when we put an X in there? Then what you're going to do is you're going to put the entire X function into the other function and answer it. The answer will have X in it. So in this case, I'm going to start at the end and work my way forward. So it's like working on the inside out. I'm going to take the entire g of x function and put it where? Into f of x. Well, what does g of x look like? G of x is 3x. That's g of x equals 3x. Exactly what I did. I just pulled it down. Now, what does the f function look like? Well, f function's up here. The f function is x is 2x minus 1. What I'm going to do is I'm going to put the g function into the f function and replace x. Let me say that again. I'm going to put the g function, which is 3x, into the f function and replace x. So it's going to be 2 times something minus 1. Well, instead of being 2 times x, now it's going to be 2 times 3x minus 1. And that's how I'm going to have to finish. I just multiply. My final answer is 6x minus 1. I cannot add those. I do not have a number. My answer is supposed to have an x in it because it says f of g of x. So my answer has an x in it. Okay. It's a little bit trickier. You're going to put one function into another function. Okay. All right. So f of h of x. I'm going to put the h function into the what? F function. I want to replace x. So if I go up here and look, this is the h function. H is going to go into f. So h function is going to go over here into f. And where's it going to change it? I'm going to put it in place of x. So it's going to be 2 times something minus 1. Well, it's not going to be 2 times x anymore because now I'm going to replace x with what? I'm going to replace it with the h of x function. And the h of x function looks like what? X squared plus 1. And now if I multiply through, I get 2 times x squared plus 1 times 2 is 2 minus 1. Final answer is 2x squared plus 1. Okay, I'm inputting one function into the other function. So just to kind of go back over it, the part that's in red is the f function. The part that's in blue inside is the what? H function. So the h function is inside the entire f function. Building a new function using 2 or more functions. This is called a composite function or a composition of functions. Okay, which one are we going to do to now in number 9? We're going to do h first. Closest to the x, come from the outside in. Where's h of x going into? Well, it's going into g of x. So let's just go back and look up here. H of x is x squared plus 1. This is h of x. Where's it going? It's going into what? G of x. So instead of saying 3 times x, I'm basically going to take out x, and what am I going to put in place of x? Well, I'm going to put what? X squared plus 1 into it. So where I used to have 3 times x, that was the g function. Now what have I got in there? I got the what? The h function in the middle of the g function. So I know I kind of made that a little bit messy looking, but I was trying to make sure that you saw I am replacing the x in one function with the entire other function. So to finish this, multiply through 3 times x squared is 3x squared, and then 3 times 1 is 3. Final answer has an x in it. All right. Number 10, 11, and 12 are meant to be final problems. This is all we're doing here is we're replacing one function into another function and building a new function. Okay, number 10 is a little bit of a challenge, 10, 11, and 12, because what am I doing here? I'm putting f of 2. Now, there's actually two ways you can work this problem, f of 2. I'm actually going to put 2 into the f function, get that answer, and put that answer back into the same exact function. So, f of 2 is 2 times 2 minus 1. Because the input is 2, and it's 2x minus 1, so you put the 2 input there, and I think that gives me 4 minus 1, which is 3. I'm going to put 3 where? Right back into f again. Well, it's 2 times something minus 1, so now my new input is what? I use the green. My new input is 3, so 2 times 3 minus 1 answer is 5. Final answer is 5. Okay? All right? G of x plus 2. Now, this is actually my new what? Input. And it's actually a description of what we have been doing up here when we did all of our composites. I put one function into another function. So I'm going to put x plus 2 as a function into what? Into G. So it says G of what? X, which is just 3x. But what if I change the input to x plus 2? Well, if the input changes to x plus 2, then in my equation, the x is going to also change to what? X plus 2. And so my function g with input x plus 2 is going to equal, and you do have to multiply, 3x plus 6. So 3x plus 6 would be the final answer. This is just a way of representing one function with x plus 2 going into it. All right, number 12. Remember when we said a composite function is a function that's got 2 or more functions? This one actually has 3. I'm going to put -6 into h. I'm going to take that answer and put it into f, and I'm going to take that answer and put it even into one more function, g. So start on the inside and work your way out. And I'm going to leave that as an exercise for you to do, and I think I ended up with a, well, let's just see. Start with h. Put -6 in there. Got to make sure that one says -6 squared plus 1. That's going to give you positive 36. So make sure that you put it in your calculator right. So the first answer I'm going to put in is 37. Now, where does 37 go? 37 is going to go into f. So now I'm going to put 37 into f, which is what? 2 times 37 minus 1. Which I think is 74 minus 1, which is 73. Now, where do I going to put 73 now? Well, 73 is going to go into G. So I'm going to go to G, and I'm going to put 73. And G function is 3 times 73. And 3 times 73 turns out to be 219. In this case, I had building a new function using 3 different functions. All right, this is your composition of functions introduction. I did all the examples 1 through 12. On the back is the homework. Notice that the first 9 are operations. This one is operations and compositions of functions. So on the homework, number 1 through 9 is actually operations. You're adding. Okay, you're adding, you're subtracting, you're multiplying, you're adding. You're dividing, okay? You are dividing. Okay, here you're multiplying 10 times the function. So here is a review of the night before. All right? Starting with 10 and even goes down through 21, I believe, this is where we do compositions of functions. So the new stuff starts at number 10, the stuff that we just went over. Take 3, get it into F, take the answer, put it into G. So you have to give these a try. Come see me at Smart Breakfast anytime if you need some help.